This came today. Anybody on the Spectrum forever knows what this is. It's a Spectrum that we saved from the paint stripper of Doom. So as soon as I've worked out how the heck Steve packed it, we're going to get it working without a paint stripper or a heat gun or anything like that, because it's not necessary. Spectrum. I've seen things packed a lot worse than that, that's fine. Samsung Spectrum. I think it's been loved. Right. It has a slightly hard life. Out the screws is a good start. Somewhere safe, and then I'll just earth myself. So, just to get rid of any static. Right, what do we have here? Samsung membrane. Good. So, first thing, check resistances. Should be just composite, that's fine, everything. Connection is good. Let's just check our resistances then. So we've got masses of resistance on the -5 volts, and we've got 2.7k there on the 12 volt, 2.7k on the 5 volt. Let's just check resistance between the two of them. Yeah, that's alright. Next thing, let's get it out. Get the board out, that is. Right, let's check his solder work. Everyone's a critic. Okay, that's okay, good. Okay, yep, that's fine, that's good. That's some quite good solder work actually on here. That's fine. Okay, I presume that's deliberate. Yes, I think it is. I know that bit. Now there's a little bit of wiring going on there, which I'm not entirely sure why it's there, so let's just check there's no short circuits. That's good, and that shouldn't connect to there, which it doesn't. I don't like that. I'm just going to push that away a bit. Right, so that is a connection here. I'm just looking at which has been broken, but I think it's, yeah, that's deliberately broken. And a free bit of fuzz. I'm reliably informed everything works ULA wise, so just checking capacitor orientation. They're all positive, they're positive. That one should be the same. That was the way. That's good, that's what it should be. Yep, you've done a good job on that. Well done, Steve. Right. I've seen much, much worse than that in terms of solder jobs. Next stage is to find out what the actual voltages are. So we need some power. Power is good for testing things. -5 volts, good. Okay. 11.8 volts, that's fine. And now we plug it in because this is what apparently didn't do anything at all. Let's see what happens. The Spectrum's working. Oh, and then it stops working. Interesting. So, it starts working, which implies that lower RAM is good, upper RAM is not so good because it booted in 16K. So there is a problem. I'm not sure what it is yet. Might be. So presumably, I heard a click from the speaker as it crashed, which is probably what Steve was talking about when he said it makes funny noises. So I think what we're going to have to do is check that the voltages are actually staying good. So let's see if I can't find a good 5-volt position. That's right, okay. There is 5 volts and that went completely kablooey. So it starts off right and then it goes wrong. But then it gets better again. Now he's already done the recap, so it shouldn't be a capacitor error. Let's check the -5 again. -5 volts is good. Right, this is where things are going to get interesting and it might take a little while. I apologise if this video becomes very boring. Transistors check out, because it worked. Transistor is alright then. The voltage lines are fine. Now I did this before he recapped it, so it's not going to be a problem on the capacitors. It's going to be a problem somewhere else. I need to find out what is causing the ULA to go kablooey. I don't like ULAs going kablooey. So, this is when we need a schematic. So, now, I might just happen to have a schematic open here. I don't know if you can see that on the video because I don't know where the camera is pointing. But the ULA should be getting 5 volts on pin 14. So let's check pin 14, which is 15, 16, which is that one, 15, 16, 17, 18, 19, 20. 5 volts, fine. So the display coming out of it is all wrong, but it's getting the right voltage. Now, obviously, the ULA I had to check. I'm assured that it worked, but I need to see it for myself. And this is an issue 3B. I believe this works. We'll soon find out. This is also a Samsung. I'll just myself. Now that's interesting, that pin was bent. Let's unbend the pin. Just check. Still bad. Okay, so it wasn't just a bad pin. Seen that happen before. No, okay. Right, this is. Can't remember if this board works. I think it does. We'll soon find out. Most of my boards aren't doing work. Yeah, it works. Good. Just make sure that the ULA stays working. It doesn't go kablamo. Because it started working last time as well. No. Right, no, that's good. That means that the ULA has survived. but I'm going to try it with a different ULA, I think, because that one might not be making a good connection. Let's have a look. The fact that it's booted up suggests to me a bad circuit somewhere, a short circuit, an open circuit. Something nasty but temporary is going on. I don't like that wire, but it should be alright. So there's nothing. I can't see anything squiffy. Okay, but we've got no picture. So could it be one of these little capacitors? Are any of them bent out of place? Are any of them short-circuiting anything? Now, the LM chip has obviously been removed at some point, or at least it wasn't soldered in right. That's a video encoder. Nothing wrong there. But a video problem is almost always a ULA problem. So let's try with. Let's find that if we just find another ULA that works to give a display. It doesn't need to actually work, it just needs to give a display. So this is my test one again. Let's just pick up a random ULA. I have plenty. All knackered, of course. Let's put this in. One of these should give a display even if it doesn't work. There we are. Right, I know this ULA. It has a problem where it doesn't find the ROM chip. The ROM chip select line has died. Which makes it a perfect candidate for this board, because I don't want to risk damaging a perfectly good ULA, but we're putting in this one, which I know works. It's a lot safer. So let's put it in and see what happens. Now this is a -6 ULA, but that should be fine because it's an issue 3B board. Even if it is a Samsung 3B, it should still be fine. Right, it still made a noise there. Doesn't like that. Interesting. Right, really bad signal. Now these little fellas here did produce something. Now let's check voltage on the LM. Although if it isn't right, we should just get black and white probably. So voltage line is 14, 15 and 16 should all be 12 volts. Right, 14, 15 and 16 on here. Yep. Okay, so number 14, 15, 16. 12 volts, okay. Now then, the display. I actually see there's a little bit of damage on this ULA. Would I like tea? Yeah, go on then, get me a cuppa. Thank you, wife. I'm absolutely sure. So I'm going to put this ULA back in here into my test one. Okay. Just just to make sure that it hasn't damaged it by being in the board. It should be right, otherwise the other one would have died by now. And indeed it's still fine. Fine as it can be. Good, so right, so the next thing we need to look at. I know the voltages are good because it booted once before it went kaputski. Let's just check capacitors again, check the right values. We've got 22, 22, yeah, and then we've got a 1, which is I believe correct, yeah. And then we've got, should have another 1, yeah, and then that should be a 4.7, which it is, good. And that's a 1. Yeah, and then this has got a 22 there, my other one's got it down here, but it's close enough, different revision. 100 micros for them two, everything looks good. 22, 22, 22. Right. This board should be working. It's not. It's a naughty board. So what we're going to have to do, now whatever is making it go bad is stopping it booting as well. It's not just the display stage. We know the RAM is basically okay. So putting on the test ROM isn't going to really help, probably. We can try it. If I can find it. Where did I put it? Hard to believe, but I do occasionally misplace things. There we go. And the problem is we don't get a display, so I'm not expecting this to do anything at all. Maybe it just sounds in pain. This is a good one, this is. Definitely not a good one for a beginner. The sync is out. I can see the sync being out. Now, the sync is out. We've got something completely wrong. Let's take out the LM chip, first of all, because we should have a black and white signal without that in, and it is a video chip. It could be destroying the signal. So let's take out the LM chip. It's not soldered in right anyway. So I should, in theory, just get a black and white picture with no LM in it, with no modulator. But it's not doing any difference. It's still the same. So the voltages are correct. I swear it must be some kind of bad connection because it booted. Some kind of right, let's think. It did boot, so the RAM was basically working. Could something be affecting the sync? No, is the answer to that. Right, we might have now changed TR2 because TR2 needs to be changed in these. Anyway, that's interesting. There's a bit of damage there as well. Let's get TR2 out. That's something has been removed, and I think the via between one side of the board and another side of the board might be bad. That's just a hunch. Certainly, some of these components are soldered in, but the pin holes in them are not good. They're actually slightly damaged. And if that's happening in the video stage, there's nothing to say it's not happening somewhere else as well. So let's just change TR2. Make sure there's no shorts. Nope, that's good. Yes, that's the right way around. Okay, so this is the Z6313 as used by Sinclair because they're better than the ones that Samsung use. But this pin socket is bad, this pinhole. No, it's going to be alright. Okay, let's... Yeah. Okay, is that good? Connections look good. Interesting. It was different. Not very different, but a little different. TR8 and TR9 could be bad. So these two are also to do with the video. But just the video, it wouldn't stop it booting, but the lack of booting could be a completely different problem to the lack of video. Let's see what happens when we try it again. Let's come back to doing that again. It's inconsistent. It's inconsistent. Nothing chromatic. So we've got a dilemma. Do we fix the display so that we can run the test ROM and find out why it's not booting, or do we fix the digital bit so that we know that we've got a display to work with? This is the problem. CPU has apparently been tested right. It's a Z80 CPU. It's a modern one. It should be fine. We need to get the video working. Once we've got the video working, we can get the rest working. But we really need this video working. I'm not seeing anything that's wrong. So having a look. Looking for anything that might be even slightly bad. No. This is all the area that's the analog part. It would be a short circuit there if anyway. But I'm not seeing anything. I'm just not seeing any damage. Right. So that transistor is good. Now what we're going to have to do, we're going to have a look at the scope. The problem is I don't like running it and I don't know what's going on. That coil does look a bit tatty, but I think it's just dirty. Let's just check these voltages once more, because I don't trust them. I never trust voltages. For the display to be bad, if the ULA was getting a particularly nasty video signal, it might have had effect. Let's just have a look at what voltage we're getting again. 4.96, so that's alright. These ones, minus 5 volts is fine. So, time for the cityscope. Which I need to plug in. There we are. Right. Okay, so positive on the inside. Tip positive means it goes in that way around. There we are. Don't normally have to break out the oscilloscope for a specky, but it does come in handy sometimes, especially on nasty little video display problems, because they're a pain. Let's just take that off. Right, now, what we want to look for is a sync signal. That's the easiest way of seeing if a signal is correct or not. Okay, let's look at it before the transistors. Oscillator, chroma subcarrier, lights. First things first, let's just have a look at the actual picture. So you probably won't be able to see that here. So this is hopefully the picture. It's all over the place. It's trying to do something. So what we should do now, let's get our little test specky again. And then let's put in this ULA will do, so working on. So we can see where the sync signal should come from, and we can compare the two. So let's just take that off. Let's just put that over there for now. Remember, this is a working spectrum. Okay. So, now if we look on the ULA, the video signal is on 15, 16 and 17. So, 15, 16, 17. So there's 15. Not very much going on there. 16, nothing going on there. 17. And that's where we get our picture. So pin 17 should have, as you probably can't see, regular sync signals. It's inverted because that's the way that the ULA creates its signal. So back to Mr. Specky. So we're looking on pin 17 and we should be getting the same signal. We should be getting just nice little mounds of sync. It's not, it's funny, it's weird. Okay, again. It starts off alright and it goes wrong. Yeah, I just saw it. It clicks on, it works, it stops working. Either a capacitor is wrong, or something else doesn't look like being run for more than 1/10 of a second, but it started off correctly. So let's have a look. Well, let's check the voltage regulator. That'd be a good start. So, so just checking. So the top pin, this should give a nice smooth voltage on this pin coming out the regulator. And it is, it's fine. Just check again. Yeah, and it uses it. So if the voltage going into the ULA is good, and the ULA picture is bad, right. So 15, 16, 17. I just want to see what they produce when they're out of circuit. Although there's nothing tying it down, so it might make a difference anyway. No, nothing at all, which is kind of what I expected because there's no load on it. Just wanted to see. So, one iced yum yum. Yes, let's have a yum yum. Intermission. Just going to check resistance on the 3 capacitors. These are on the 3 display lines. That's alright. That's alright. Just in case they've gone short. Does happen. Yep, nothing funny there. So, let's have a look. What's the resistance between video and the ground? It's high, that's where it should be, yeah. Not that direction, it isn't. $70 ohm. The resistance using the video output as a ground is no, of course it's plugged in. Let's unplug it. Now we've got a resistance of 387 ohms using video output as the common. So compare with our working one, it's about the same, 390, so that's fine. Let's check. Other way around is also 390, probably is on this one too. Yeah, that's fine. Okay, now resistance to ground. So we've got 950, 950-ish, 830. $950, 950, 830. So there's no obvious shortcuts, no short circuits. But there is no reason for the ULA to kick out a bad signal. Unless something... I think my wife just died. What was that noise from? Was your coffee that bad?
I ate too much.
You ate too much. One thing's for sure, I wouldn't wish this spectrum on a beginner. So, randomly check a few capacitors and make sure they've not gone short. It does happen. And they can be a real pain to work out.
Happy. I need to stop again.
Alright, part 3 coming up.
Wait.
Okay, so, where have we got? Nowhere at all! Hey! Let's check the 5-volt line and the oscillator line. So let's just check pin 14 using the scope. Should be the same, should be smooth. Oscillator is not in very well. I don't think that will make any difference. Sure there's nothing to short it. We wouldn't like it to start working, would we? Right, 14, 15, 16, 14. That's fine. And it always makes that pattern. Seriously messed up. This is the most messed up specky I've seen in ages. Which makes me think... I'm not willing to send it to the paint stripper. Right. Right, what could be wrong? Well, if the source is wrong, if the ULA is kicking out a bad signal, then the ULA must be not working right. If the ULA is not working right, there must be a reason why the ULA isn't working right. The ULA is good, but it's not working. I'm wondering if there's anything nasty underneath that socket. Because when I run this, remember this is a faulty ULA.
I know what it is, I have looked it up here.
My wife has worked it out, go on.
It's a ULA incompatibility.
No, it's not a ULA incompatibility because this is a -7 and they work with anything. And I've tried 2 different ULAs. But nice try.
I know what you should do this. Take this colorful thing with colorful wires and stick it to all the USA legs and see what it says.
Well, this is what I'm thinking. When I look at that, I get just a nice, clean little sink. But I don't get that.
I think it's called Logic Analyzer.
Yes, the logic analyzer is something I will be looking at soon, but it's not going to help with the video, which is the problem. And it's not really going to help with the digital. I really need to get this display working. But why did it boot and then immediately crash if it's not a capacitor? I keep coming back to capacitors, but he's changed to capacitors. Which means it would have to be one of the disc capacitors, which don't really go wrong. Or very rarely anyway. This is a real puzzler. Everything's in the right way round. Right, okay, so what would make this go different? Pin 17 is wrong. If pin 17 is wrong, there must be a good reason why pin 17 is wrong. Pin 17 is always created with a sync. The sync is not right on this. Therefore, pin 17 isn't good. So, let's check some resistances again. So 830 ohms, that was right, that's what we got on that as well. So 1.83 ohms to 16 and 11.3 ohms to 18. Which is correct. Yeah, that looks fine. So it's 25 now. Pin 25 is a slightly different resistance. That's the data line. That's 3.9, whereas to 27, it's 11.3. Just check that. Right, so measuring pin 17 to pin 25 on the working board, so that is the effective sync to pin 25, which is the 4, I believe. No, D3. That gives 8.33, and pin 27 gives 8.33. On here, measuring from 17 to 25 gives 12, and pin 27 also gives 12, which I'm sure it didn't do a minute ago, interestingly. So that's correct. The important thing is that they both give the same amount. I'm sure it was something different a minute ago. Okay, let's just try again. Okay, that doesn't work. Tell me something I don't know. 17 to 25 is 6.8 and is 6.8. Fair enough, that's alright. So, let's see what we've got. Are there any bad looking connections. So we've got 3 kilo ohms to pin 31. I believe 21, 2, 3, 4, 5, 6, 7, 8, 9, 30. No, pin 32. Now pin 32 is, that's the clock. So let's just check. Pin 32, it's 3.2, fine. And then we're up to 8.6, that's fine, yeah. And there's 28, pin 28 is is somewhere I can't see. Oh, that's the mic. That's the mic. Which is 2. Yeah, it's fine. Yeah, back out to 8. So there's no obvious shorts on this line. It's 1.8 between 17 and 16. 1.8, yep. Right, so let's check. Now then, it does go up to the expansion bus up here, which is completely the other end of the board. There's a lot to go wrong there. What is this wire? There's a little wire down here. Now, what does that do? I mean, obviously that shouldn't be there, so why is it there? Right, now this is a slightly different revision, unfortunately. But effectively, that is connecting to there. Well, I'm not seeing anything yet, but that might just be me. Right, okay, so it is hitting that. I'm not getting that connection. They're inverted. They're the wrong way round. They've turned it around. Right, okay, so that should be connected to there then. No? Right, so what line is this? Okay. So that is connected to there. It's not connected to that. Doesn't seem to be connected. There's a modification here and I don't know why. So what it's connected to is a transistor. And now it's actually being used as a cathode of that, so it should be connecting to there. Yeah, which it does. Is that just connecting to ground? it's not. Right, okay, because the transistor's been moved. Right, I think that's alright. And my telly is just timed out because I'm taking so long. I bet it's something blooming obvious. Usually is. I still don't like this socket. I don't see why the sync should be bad. The ULA can't produce a bad sync. If it's producing a good signal, then it's producing a good signal. It's as simple as that. Let's just have a look. That's not the right signal. The actual sync pulse is wrong. It's a square. That's why it's so dark. There's no back porch. It starts off producing a back porch and then it disappears. So it's only producing a third of the actual sync. Now, if it's only producing a third of the sync, right, let's have a look then. TR8 and TR9 should be connected to its particularly TR9. TR8 probably won't matter. TR9 definitely does. So we get 100, we'll get 900 out of that. I'm just getting 1 there. And that's reading 910. I'm measuring it on a diode setting. This is TR9 I'm looking at. That's TR8, that's TR8. That's 900. Which is correct. Okay. Let's look at TR9. 900. Then there's 1. And then there's 1. 900. Not. That's alright. I mean, that's not a proper test, but there's no shorts or anything. Something is stopping it. Right. Now, C8 is a decoupling capacitor. There's nothing wrong with C68. Probably. But it's getting affected could it be TR1 as a resistor? There's a 4K7 at R48. Slight discoloration there, nothing to worry about. Let's have a look. There's 1.7 K between them. So that's correct. Gosh, this is a tricky one. I'm looking at all these capacitors. Right, let's try a slightly different tack. Let's check our resistances on the data bus to ground for any shorts. 7.9, it should all be the same. 7.9, 7.9, 7.9, 7.9, 7.9, 7.9. Yeah, they're all the same. Check for anything different on the address bus. The only thing I can think of is something shorting between the video section and the digital section. The only reason I can think of why both would go bad, I need that schematic. No, there's nothing funny there. Tricky. I'll have to think about it.
Nice.
Okay, right. So in the meantime, while the camera had disappeared, I have made absolutely no changes whatsoever, and it still sounds horrible. What the thing I'm going to do is I'm going to remove the CPU, but we don't need it. Right, we'll take this out at the moment. Let's see if there's any difference at all. Well, what do you know? So something is messing up the bus. Now this is a 20 megahertz CMOS CPU, which is a far cry from a standard Z80. So, what we're going to do, we're going to get a normal Z80 and we're going to try this. So the Z80 is completely separate to the video stage on the spectrum. So it shouldn't make any difference at all unless something's badly wrong. Now this is a D780C1, it's exactly the sort that Sinclair used a lot of. Let's see if this works better. Nearby pins. Still bad. Right, okay, so we know it's not the CPU. Let's just check the CPU in here. But we do know that the CPU is messing it up. We know that when the CPU is not in, so this is my board at the moment. This is the original, this is the 20 megahertz CMOS CPU. Let's just see what happens when we run it in a working board. It works. And we knew it worked because it booted as soon as we started it up. The first time when it worked. So we're barking up the wrong tree if we're looking at capacitors. It can't be capacitors, because if it's capacitors, then it's not going to make any difference. So let's have a look. This has got the CPU in again, so this should be bad. And it is, it's all over the place. We take the CPU out. And we should get a black and white screen because there's no LM chip. Perfect. Now we can see it's stable. There's no problem. That tells us that something on there is interfering with something on there. Right. And of course that's why it's not working, not booting and not displaying right, because that is stopping the CPU from executing and the CPU is stopping the sync from running. Right, we're making progress. So let's take the heatsink off, preferably with the right screwdriver in. This one will do. So that I can see. Now, I don't know how well the CPU socket was soldered in. I don't know who did it. I don't know how good they were. It may well have been Steve, and he did alright on the capacitors. So. But we don't know. Now, let's just have a quick check. There is evidence of being cleaned. There's little hairs on it. Nothing particularly bad. Yes, something on there is destroying that. So, let's find out what it is. So looking on a schematic, Z80, let's take out pins 14, 15, 16, 17, 18. So that's 14, 15, 12, 8, 7, 9, 10, and 13. Okay. The reason for that is all the data bus. So this should tell us if the data bus is what's destroying it. Now, that little heat regulator needs a heatsink, but I want to be accessing that CPU, so I'm going to put a little temporary heatsink on, just to take off some of the pressure on the poor thing. It won't run for massively long like this, but it will be enough. So let's see what happens to the display. So there's no data bus activity now. It's bad, in a predictable way. It was steady bad. Okay. Now let's do the address bus. Actually, before we do the address bus, let's do the clock, because the clock is important to both the ULA and the CPU. So now we've got no clock access. And it's fine. Okay, let's put the data bus back. No, actually no. The clock to the CPU comes in from the transistor from TR3 from 32. pin 32 on the ULA. Now, if the clock is wrong, now, but what we don't know is it might be the activity on the address bus. So, as soon as the Z80 does anything, it changes. Now that's TR3. Okay, so all we know is that the Z80, when it does something at all, destroys the video signal. So we need to find out why. Right, so pins 4, 5, 3, 36, 2, 35, 1, 34, 40, 33, 39, 32, 38, 31, 37, 30. That's the entire address bus as well. So now the CPU is going to run, but it's just going to have garbage. If it's the clock that's affecting it, then the display will be bad. If it's the bus that's affecting it, a display should be good. Display is good. So now, let's put A0 back on. So that's pin 30. So 21, 2, 3, 4, 5, 6, 7, 8. Okay, so A0 is now valid. That's now going to be going between 0 and 1 in the ROM. So it's not going to do anything useful, but it's going to do something. The display is bad. So let's lift A0, and then let's put A1 in. A0 does have more attached to it than most things, so it's more likely to be wrong. A1 is the pin next to it, it's 31. So I'm guessing this is going to be a good picture. Could be wrong, could be very wrong, but I'm guessing this is going to be a good picture. Right. In fact, I'm going to guess that if I put all of these pins down, it's still going to be a good picture. try it. So all of those address pins are now in. And it's still a good picture. Okay. So they're all down as well. In fact, tell you what the heck, let's put all the data lines down as well. Let's put everything down except for A0. Okay. A0 on its own is out. Picture is good as I suspected. Now if I put A0 back in again, it's going to stop. So, now A0 is of course connected to the ULA, the other pins are not. In fact, A0 trundles along TR6. Attaches to IO rack. That doesn't make sense. So chug. Blomp. Is that A0? Yes. Because that's how the ULA knows that it's being accessed. What happens if we lift pin 33 on the ULA? So A0 back in now. Three, 40, 39, 8, 7, 6, 5, 4, 3. It's pin 33. Okay, so the IO that was not a deliberate, right? These pins do get bent. This is why I use a test ULA, because every now and again a pin can find its way out. This will be interesting to see what happens. Okay. That is the correct pattern for this ULA. So, obviously the next thing to do there's myself again. 2, 3, 4, 5, 6, 7, 8, 9, 30, 1, 2. There's pin 33. Let's lift that up. If I'm right, then this will boot. Yeah. Now of course it's got a black border because it doesn't know about IA requests or anything like that, but it booted. Black and white because there's no video encoder, there's no LM chip. So all of that is just a red herring. That's all working fine. So the obvious thing to do is to check TR6. So let's put Mr. Test ULA back in again, this time with pin 33. Okay. Let's whip this out. TR6 on a Samsung board should be a ZTX313 anyway if you're going to be using any kind of expansions, because these little guys, C945s or whatever they are, struggle, especially with interface ones. So you now need, this is my transistor bag, it has transistors and clocks installed and anything like that. But most pertinently at the moment it has my bag of ZTX 313s for the win. Should always have a ZTX 313 bag handy when you're doing specs. Since I don't have you. And this is when you realise that you can't remember where you put these. Now then, what's going to happen? That's what I wanted to happen. Because that's the right pattern for this. Bad socket. Earthing myself constantly just to make sure, because I'm dealing with ULAs and I'm paranoid about ULAs. Hopefully this will work. Oh look, 1982 Sinclair Research Limited. Now that was 16K. Quite obviously. But the next thing to do is to get this little fella back in properly, unlike when it was in the first place. So that we've got colour again. Because we like Technicolor as spec users. So, where have we got to? Now this has probably got a dirty expansion bus, which is probably why it didn't like the test expansion. There we are. Right, so we've got now 0 is good, 1 is good, 2 is bad, so that's bad. 3 is good, 4 is bad, 5 is good, and 6 is bad. So, 0 is good, okay. So we've got IC 17, 19 and 21 all need changing.
Oh god, oh god, it's here, Ian, it's here. Please take it away.
That's why I found them all.
It's huge. No, it's Daddy Long Legs.
Daddy Long Legs, was there?
They're heavy. It's the rabbit
imagine it's Daddy Longlegs
Yes,
size.
it is happy.
This happens a
Please
lot.
take it.
I can't take it. I'm busy recording myself fixing a spectrum.
Can you close the windows?
You can close the windows if you want. The one that you can't reach isn't open. It's only the one at the end which you can reach.
I can't use my computer anymore.
Can you not? Why
Because
not?
it's sitting here.
Where is it sitting?
Up here.
Here, where?
Here. It's up here. Look.
And that's going to stop you using the computer
Yes,
anymore?
because it just flew.
Did it?
Please help me.
Well, you know where the bug catching device
No,
is.
please help me. It has wings.
Yes, I know it has wings. It's a Daddy Longlegs.
I'm scared.
It's not going to hurt you.
Please help me.
I can't.
Please stop this. Help me, please. Please help.
Wait a second.
Before it moves.
Yes, if it moves, then it's no longer by your computer. It's not a problem anymore, is it? Hang on. Ah, dear. It's not awful, it's natural. It's just a Daddy Longlegs.
Take it, Ian.
Yes, alright, I shall do, but I need to finish off this.
I can't.
Now there's one little connection that's causing trouble.
Help me.
Yes, alright, I'll be there in a second.
Please be here now.
I need to be there in a second. Oh,
Help me. Please help.
there we are, got it. Oh, right, okay. Where is the Daddy Longlegs? Are we going to edit this bit out?
Look, it's, you can't hear, see it because it's camouflaged. It's
Yes.
sitting on my.
That was just my
Oh,
finger.
it's sitting on my postcard.
Oh yes, there it is. Hello. Right, okay. Where's the bug catcher?
It's there.
Is it? It's where?
It's right to you.
So no, oh, there it is.
But it's not big enough for it. It's huge. It's gonna fly away. Please don't let it fly away.
Right. Okay. No, that is a large Daddy Longlegs. But
Great, you got it. So it's not going to fly anymore. Okay, so I'm glad it didn't fly away. But don't.
come on, you're gonna. That's it. Come on.
It's moving. Look at the leg.
No, don't.
No, don't let it go, Happy.
Come.
Don't let it go. It's trying to escape. Don't let it fly away. Come on, close it. It's awful, Happy.
Come on.
Right? Don't let him out. Whatever you do, please.
There he is.
This is awful.
Come on, let's get him out. Can you come and open the door? So, after that little nature program, we've got that one's come out, and this one next. Just going to get that screen. Don't worry about that, that's just because of interface. All that's probably just a connection. Looking good, Houston. Right, still got RAM error. Right, I'm going to have to find another 16-pin chip, aren't I? Right, what I need to do now. Well, there's more than one thing I could do, but what I'm going to do is I'm going to grab a keyboard. Can you see the screen, by the way, on the recording?
Me?
On the
Oh, a little.
a little. Okay. Better than nothing. So. So we've got an upper RAM fault. So it started in 16K mode, usefully. Go tool, window, hex, C000, shove us straight into the upper bit. Now this should be O2s, but it's OA, which means that D3, which is O8, is bad. Because the memory should always, it starts at the top and writes O2 to everything. So if it's got an OA in it, O2 would be that one. But if it's OA, then that one is also set to 1, and it shouldn't be. So that chip is bad. Out it comes. Membrane test. Faulty line on the ASDFG9, but it's unlikely to be a serious problem because this is a Samsung and they're pretty good. Interesting. One of these lines, but it's let's just have a look, see if there's any breaks. I can't see any breaks. I do occasionally need a bit of a clean, as do the sockets. It's more likely to be the sockets. Okay, so we've got a problem there. Right, next thing to do. Confusion. Is it making any connection there? So, that one is. 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 Yeah, that one is. That one is. That one is. They all are. Could he actually have a broken Samsung membrane? It seems a bit crazy. I suppose it could happen. I don't very often break. I don't think I've ever seen one that's broken. So. Right, I think this specky is a working one. It's got a heatsink relay, so I suppose it must be. Yep, so let's try the membrane in here. And that'll tell me whether the membrane is at fault or the specky. The membrane is. Seen a properly broken Samsung membrane. Really look fine. looks like it's bad. It looks like somehow we've managed to get a dead Samsung membrane. Well done, Steve. So I'm trying to find a crack. I'm not seeing anything.
Why?
No, it's not that. It's not a matter of insulating tape. I suppose we ought to make sure, actually, maybe it's not an insulating problem, but let's just have a look at it first of all. Can't remember which line is the important one. Something like the third one. I don't know, make a connection. I'm not seeing anything wrong with it. Let's just connect the debugger on again. That's just a ROM affecting it because it's one of the chips has come loose inside it or something. It does that annoying. Right. Or it might have just been a dirty edge connector in case on that machine. So we've got weirdness going on up here. What's the ULA display block? I think it is doing something. But because there's a problem with my diagnosis ROM at the moment, it's hard to say. That's what's affecting that. Right, let's check it with a normal membrane. Looking right. Yeah, it's fine. It's just the end of the leg get a bit worn out on these membranes. Need to trim it back a bit. This one isn't. Now what I think might be the case is just a bit too much resistance. So just going to trim it back. just like I would with a normal membrane. There we are. So it's just slightly shorter, which will make it make connection in a different place on the membrane. It might be enough to make it work, because I think it's fundamentally alright. But not this time. No, everything other than that line. Tricky. Naughty membrane. How many minutes left?
It doesn't say, Happy.
Is it not? It is definitely recording, isn't it?
Yes, Happy.
Well, there's nothing wrong with that. Just check. Okay. Now, I would hate to take this membrane off badly because I might damage the fascia. Ha ha ha. Let's have a look at this membrane and see if we can see what might be wrong. Try not to bend it too much, although I suspect it might need a new membrane anyway. A new fascia anyway. Now, looking at that, I can't see anything wrong with it at all. Okay, membrane out. Now that might be it. It's got wet. And it's got those gunk in it. Right now, well, if it's been gunky once, that means it can be gunky again. Now, never done this before. What could possibly go wrong? And the problem is simply the membrane's too dirty. It's got wet, the moisture's got inside of it, and it's gunked up this row of letters here. So let's check if there's a connectivity there, because there should be. This line here should connect to there. It doesn't. That line should connect to there, which it does. That line should connect to there, which it does not. So, what we need to do is find out where the break is. So that is a contact there, but it's broken here. That is not making contact. That is. We've got a little bit here of corrosion. I can see it now. Just a tiny little bit. But it's enough. Yeah, there's the break. Right. Let's sellotape. Just there is the problem. So Even one uses for sellotape, repairing spectrum membranes. If you just smile. Okay. There we are. Sellotape around the brake. Now, somewhere in here, somewhere out there, we have this. First check I've masked it off correctly. It's not perfect, but it will do. Now then, I don't have a paintbrush, but anything that I can use, fine. I just need something to dip it in and get a bit out, and then take it back. So. Guaranteed to make a mess. Give it a good shake. Open it carefully so that it doesn't end up on your shirt. The more expensive the shirt, the more likely it is to happen. And just get a little bit and paint it. Not black, like the Rolling Stones would do. Paint it silver. That should do it. Want it to dry. Blowing on it will help dry it. And it's already starting to conduct. Yeah. This should now have dried. Yeah. Now we take off the sellotape. Masking tape would also be useful for this. Probably more useful because you can see where it was going. But I don't happen to have any masking tape at the moment.
See one? Look, the blue one.
Oh, yes, I could have used the blue tape, couldn't I? Yeah, my wife knows best, as usual. Right, so let's take that off. And hopefully it hasn't taken off any of the rest. Here we are again. I've just taken off the fascia and put it back on again because it was a little bent before, so I've just unbent it. It happens when you have to take it out all the time. Next thing to do, 3, 4, 5, 6, 7, 8, 9 knots. QWERTY Europe, A, S, D, F, G, H, J, K, L, enter, Z, X, C, D, B, N, M. Right, yep, done. Should load. Right, that's obviously working. Let's try an interface 1. And what else can we try? See if it works alright. Let's have a Mirage microdriver, which I've been helping fuse chaps with. Let's see if this works. The edge connector might still be a bit dirty, but it's worth a try. Okay, let's see if this works. No, that doesn't work, but that might well just be dirt on the actual interface 1 edge connector more than anything else. Let's just try it again. Oops. Or it might be something else that I've done wrong. Let's see if it... Right, it has access to the microdrive, but not the Mirage microdriver. I'm sure that was working earlier. Somewhere around here I have a Mirage microdriver. There we are, that one will do. Because earlier on today, the other one just needs its thingy cleaning. I couldn't remember which one was a good one. Let's load Automania, which of course is a 48k game. Chug, 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 chug. Run. Sorted. Okay. Not sure if that was supposed to happen or not, but hey. Right, let's... this card I think format's alright, sometimes anyway. Oh, it doesn't like it. Okay, let's... Still got a dirty connector as well, let's take that off for now. I think this one will be QL formats actually, so let's see what happens when I format it. Samsung Spectrums usually have a problem with formatting cartridges because TR whatever it is, 6 isn't very good in them, but as I changed it to make it work anyway, not a problem, or was it TR3, whichever one it was, I changed it anyway. 92, there we are, sorted. Yes, it was TR6 on the IO9. So that is now a fully working spectrum. Thank you very much.